A discussion about storm drains and wastewater might not seem to many to be an exciting or an important discussion, but it's a discussion that's critical to our health and the health of our planet. Find out why on Talking with Henrietta, coming up next. Hi, I'm Henrietta. Welcome to the show. We hear a lot these days about global warming, greenhouse gases, and the pollution of our streams, rivers, and oceans. But did you know there are things being done on a local level to combat global warming, the buildup of greenhouse gases, and the pollution of our waterways? Have you heard about the Regional Water Quality Control Plant and the partnership that exists locally between several cities? On this show, I have three guests who will talk about that partnership and discuss what's being done to treat our sewage, recycle water, free up our landfills, and keep our rivers and streams clean. Seated to my left is Dennis Schertzer, who is presently serving his 7th term as a member of the East Palo Alto Sanitary District Board of Directors. He served as the district's general manager from 2000 to 2002. He is an environmental scientist, and he has been engaged in intensive study and research regarding solutions to the climate crisis and greenhouse gases. Phil Boble is seated to my right. He is the manager of the Public Works Engineering Department for the City of Palo Alto. He has worked on some of the U.S. Environmental Protection Agency's early water, air, and hazardous waste programs. He received an outstanding award in 2014 for leading the City of Palo Alto's award-winning pollution prevention program, for demonstrating leadership in public education, and for documented reductions in water pollutants in our wastewater. Akintunde Akupe is the general manager for the East Palo Alto Sanitary District. He was born in Lagos, Nigeria. He has over 25 years' experience as a civil engineer. He became a registered civil engineer with the state of California in 2005. And over the last 15 years, he has worked as a design engineer and senior civil engineer for the California Department of Transportation, the El Dorado Irrigation District, the City of Woodland, and the City of Sacramento. Well, thank you so much for joining me. It's a pleasure having you here on the show.
Thank you.
As I said in the introduction, our storm drains and the wastewater is something that's critical to our health and the health of the planet. So let's start with that and just say generally if that's true, if it's not true.
Absolutely, it's true.
Why?
Well, water is essential for all of us. And like I like to say about the wastewater treatment plant, what they do there is they separate water from everything that ain't water. And that's a very important thing to do, because those contaminants in the water make it unusable for humans and make it very detrimental to the environment. And as one of the custos said in a presentation a few years ago, that in California, the wastewater districts in California keep the sewage of 36 million people out of the ocean every day.
Phil?
Yeah, we're proud of that. You know, we realized, or the people that came before us realized, that in the 50s and the 60s, we were just dumping too much stuff, untreated sewage, into San Francisco Bay. And the bay was literally dying of its own weight because of all the algae that was growing, all the nutrients that were going in, and the
And when we
organic.
talk about the San Francisco Bay, we're talking about the bay actually in San Francisco, around San Francisco.
Well, not just around San Francisco, but you know, it comes all the way south,
down through San
beyond,
Jose.
yeah, south of the Dunbarton Bridge, and
So all of that area
yeah,
was
so
dying?
every little city was discharging into San Francisco Bay, and we were having fish kills, and that was our first clue, is hey, the oxygen level has gotten too low in the bay because of all the organic stuff we were putting in there. And this was kind of realized by the early 60s, and by the late 60s, the federal government was funding sewage treatment plants to be upgraded, built where they didn't exist, all around San Francisco Bay. So today we have about 30 wastewater treatment plants treating the stuff, removing organics, so that when it's discharged to the bay, it doesn't lower the oxygen and kill fish like it was doing.
Sure. Now, Aiken, any comments?
I think what Phil just said now, to me, makes a lot of sense. The problem in the 60s actually emanated into the Safe Drinking Water Act of 1972. And the purpose of the Safe Drinking Water Act is actually to control contaminants in drinking water. Because when it gets into the stream and into the ocean, some treatment plants tap this water and treat it for beneficial use again. So if the contaminants loading rate or concentration is not controlled, then it becomes even more expensive to treat this water for consumption. So,
Now, Phil, you talked about in the 1960s that this started.
I, of course, wasn't born, but
Oh, none of us, right? What started that awareness?
well, I think it was literally dead fish.
Oh,
Yeah, they were having fish kills, and they were trying to figure out why, and then they monitored the water, and they said, well, the dissolved oxygen, the oxygen in the water is too low. Fish need oxygen just like we do. Of course, they get it from the water, and it has to be at a certain level to keep species alive. And so when they started dying, they started testing the water. Oops, it's because the oxygen content is too low. There were other problems too, but that was sort of the most fundamental one. Nobody likes to see dead fish, right? There were other things that were building up in the bay. Toxins were building up in the bay, but that wasn't recognized till later. The earliest problem that everybody noticed was the low oxygen, the dead marine life.
oh dear, sounds pretty serious.
and that is why even up till today, if you look at the wastewater treatment technology, we pump here in order to actually activate the destruction of the microorganisms. We actually aerate it. But if you don't aerate it and you allow this waste stream to pass onto the ocean, then they take up the oxygen in the water. And that is what Phil was talking about.
Sure. Now, we will be talking about the Regional Water Quality Control Plant and some of the issues involved. But I thought a good way to start would be to see a short video that talks about it and talks about how the wastewater is cleaned. So we're ready for it. As soon as you have it up, let us know. And in the meantime, while we're waiting for it, perhaps we can continue on. Oh, here we go.
Almost every drop of water you use at home, school, or work drains to the San Francisco Bay. Our bay is the largest estuary on the West Coast. It's a place that serves as nursery and home to wildlife, including endangered species and millions of birds using the Pacific Flyway. Like a natural sponge, the Baylands ecosystem reduces flooding and is responsible for a wonderful Mediterranean climate. Before modern wastewater treatment and Baylands conservation efforts, garbage and dirty water from homes and industry were released directly into the bay. The pollution and decaying waste made it difficult for the bay to sustain life at the water's edge. But in 1970, federal law was changed to require communities to protect local waterways by cleaning and treating wastewater before releasing it. Now, to protect the bay, the City of Palo Alto Regional Water Quality Control Plant treats up to 20 million gallons of wastewater each day, collected from the homes, businesses, and industrial facilities located throughout its 6-city service area. Wastewater travels by gravity through the sanitary sewer system to the plant, which then uses a series of physical and biological processes to remove large and small pollutants. The wastewater undergoes preliminary, primary, secondary, and tertiary treatment before it's released to the bay. In the first step, preliminary treatment, large solid materials are removed as the wastewater passes through bar screens. Next, during primary treatment, the water is pumped into tanks where smaller solids settle to the bottom or float to the top, where they are collected for later processing. You've seen how water in a river or stream bubbles over rocks. The next step, called secondary treatment, mimics this process of aerating water to provide oxygen for the bacteria which eat biological wastes. Wastewater is sprayed through large plastic plates in trickling filters that are covered with a slimy layer of microorganisms, including bacteria, protozoans, and fungi. Like us, these microorganisms need to eat, except their food is human waste, traveling from our homes, schools, and work. From there, wastewater moves into aeration tanks, where ammonia, another component of human waste, is consumed by different microorganisms. In some cases, primary and secondary treatment clean wastewater enough so that it can be returned to nature. But because South San Francisco Bay is a delicate and fragile ecosystem, the Regional Water Quality Control Plant adds one more step, called tertiary treatment, to filter more pollutants. During tertiary treatment, tiny particles of waste pass through fine sand and coal filters, imitating how nature cleans water when it passes through soil. Then, ultraviolet light is used to kill bacteria and viruses without using chemicals. This UV light destroys the microorganisms or damages their DNA so that they cannot reproduce. Finally, about 22 hours after it first enters the plant, wastewater is clean enough to return to the bay. Most of the water is discharged into the Palo Alto Baylands, but about 1 million gallons each day is also released to Renzel Marsh, a reconstructed wetland east of the Bayshore Freeway. It takes the water about 12 days to pass through the marsh before entering Matadero Creek, where it travels into the bay. Back at the plant, the leftover solids, called sludge, are dewatered, ground up, and incinerated to become ash before it is sent to a landfill. Soon, incineration will be replaced with a more environmentally friendly process that converts sludge to energy and a reusable fertilizer or land cover. High-quality recycled water is another byproduct of the Regional Water Quality Control Plant. 1 million gallons of recycled water are generated each day. Recycled water is a safe, reliable, and valuable alternative source of water to use on landscaping, in fountains, and for industry. Using recycled water for these purposes conserves drinking water, and its use will only become more valuable as our population increases and adjusts to climate change. The services of the Regional Water Quality Control Plant are critical to keeping San Francisco Bay healthy. Because of wastewater treatment processes throughout our region, pollution in the bay has decreased substantially in the last 50 years, and the health of the bay has improved. But the plant can't remove all types of pollutants. Although it was designed to remove biological wastes, many of the chemical compounds sometimes flushed down sinks or toilets cannot be fully removed, so we need your help. Remember, only water, human waste, and toilet paper should be flushed. Hazardous wastes such as medications, paints, chemicals, pesticides, and fertilizers should be brought to a household hazardous waste facility. Pollution from runoff traveling into storm drains is also a challenge. Rain and irrigation carry pesticides, oil, and other pollutants from yards and streets straight into storm drains. From there, the water goes directly to creeks in the bay with no treatment at all. To prevent stormwater pollution, never dump or wash any pollutant into a storm drain. Because home pesticide use is the #1 source of pesticide pollution in our creeks and bay, don't use pesticides outside your home. When servicing your car, make sure to avoid water pollution. Recycle motor oil and radiator fluid. Use a commercial car wash which recycles dirty wash water and keeps it out of storm drains. If you wash your own car, keep soapy water, even when using biodegradable soap, away from storm drains. Use a cloth and a bucket of water, not a hose. Dispose of wash water in a landscaped or dirt area. Pet waste can carry diseases and causes problems when it gets into a storm drain and ends up in a creek where wildlife lives. Pick up after your pet. Never drain pools or fountains to storm drains, where pool chemicals can kill insects and fish. If you have a swimming pool or a hot tub that needs draining, be sure the water is emptied to your property's sewer cleanout. Understanding the value of wastewater treatment and the importance of preventing stormwater pollution is key to protecting the bay. Remember to do your part to help preserve this spectacular resource we all enjoy.
Well, that certainly gave us an overview of what the treatment plant does. Anything that was left out?
I think it touched on everything. You know, there's a whole other layer of depth about exactly how the treatment occurs and our future and the toxic substances. So we can get into any of those topics that you'd like to, Henrietta.
Sure. Well, it talked about incineration that will be replaced. Replaced by what?
Dennis always has ideas on that.
Well, in the conversation on the replacement technology, it would, as it stands now, would be one form or another of a gasification technology. What was originally recommended was a biological gasification technology that uses anaerobic digesters.
Now, can you explain for the audience what's gasification?
Gasification is a process that turns a solid material into a gas. And the two ways of doing it in sewage treatment is either with bacteria, as we heard about the bacteria consuming it, or with heat, thermal process. And the proposed anaerobic digesters is the reaction chamber where the bacteria do their work. And what happens is the bacteria act or interact, eat the organic molecules, the food molecules, the organic molecules, and they break them. And when they break them, they release carbon dioxide and methane because they can't destroy the matter. You can't do that. So they just modify it. And the process is sort of, if you've ever picked apples and you put the bruised apples in a bucket and it's in the sunlight a little bit, the first thing they start to smell like wine. They're fermenting. That's bacteria changing the sugars and stuff into alcohols. And then they'll start to smell like vinegar. And that's turning it into a substance called acetic acid, which is what vinegar is. In the store you buy white vinegar, it's 5% acetic acid, 95% water. The acetic acid molecule, and I don't want to get too technical, but it's made of two gases, carbon dioxide and methane. So the final process, the methanogenic, the methane generating bacteria, break that molecule and releases CO2 and methane. And then the proposed process was to collect the gases, separate the methane, then use it to fuel a stationary engine, which would then run some type of electrical generator. Thermal gasification doesn't rely on the bacteria at all. And it uses a chamber called a retort, and it uses heat. And any carbonaceous material, which is about 80% of municipal solid waste stream, can be gasified by this process. And when it's heated in the box, no direct flame, it's heated in the box, the gases get drawn off, and that's what's burnt to generate the heat. And the solid product that comes out is carbon, which is inert and which is usable as an industrial product. And when the gases are burnt, this mixture of gas is called a synthetic gas or syngas. And all the gases, including carbon dioxide, get burnt. And the unburnt gases recirculate and they get burned again too. And that's
the process that you would advocate.
Right.
Okay, what's the process now?
Well, we're starting to come around to Dennis's way of thinking. So right now we have this incinerator. The problem is we have two incinerators. The problem is that it takes a lot of energy to run an incinerator. It's very high temperature. It's higher temperature than the thing Dennis is talking about. Very high temperature, so it uses a lot of natural gas in the process. It's a big energy hog. Plus, worse yet, it produces CO2 gas, right? You're oxidizing all this stuff and the gas that you put into it. So it's a greenhouse gas source. It's actually one of the largest greenhouse gas sources in Palo Alto, if not the largest.
Polluting the atmosphere.
Yeah, sending greenhouse gases into the atmosphere. So we want to stop that as soon as we can. And we're on track to stop it early in 2019. So we're on track to get the old incinerators offline. And what Dennis is talking about is, as we look forward, there's these two sort of basic choices. And the one is kind of well established, using bacteria in digesters. Almost all sewage treatment plant, that's what they do. They just put the solids in a great big tank and let the bacteria go to work on it.
But that creates sludge, does it?
It does. You
And
have
the
leftover
sludge
stuff.
goes into
Well, we wouldn't put it in the bay.
But it does, it's part of the compost, would it be?
It should be composted, right.
And you mean to tell me, I've gone to the Palo Alto dump and I've gotten compost, so I've gotten some of that sludge?
Well, not in the past. In the past, the compost you get is produced purely from food scraps and stuff like that. So what we're talking about would be possibly using sewage sludge in compost, but we're not doing that locally. They are doing it in other parts of the country.
But the sewage sludge has a lot of harmful chemicals.
Well, that's the problem. That's the debate.
And I think you had even mentioned what, tomato?
Oh, that was in the San Francisco example. The city of San Francisco provided sewage sludge-based compost to community gardens. And what happens is things like flame retardant washes out of clothing, those type of things, the bacteria don't destroy that. And these showed up actually in the tomatoes that people were growing in community gardens. They were tested.
Fire retardant
Fire
tomatoes.
retardant tomatoes. Yeah, tough to roast on the barbecue, I think.
Oh, who would want to? So, Aiken, you've been quiet for a while. Any comments?
I think what Phil Bobo just said makes sense. The regional plant are trying to move away from incineration, and but what Director Scherzer is trying to point out is that if they're moving away from incineration, they should be going in the direction of pyrolysis. That is what he's talking about. And
Pyrolysis?
Pyrolysis.
Pyrolysis.
Yeah.
What's pyrolysis?
Pyrolysis is the thermal decomposition of the biosolids, at high temperature. Where incineration occurs at around temperature of 1500 degrees centigrade, and pyrolysis occurred at around temperature of 750 degrees centigrade. But the difference between pyrolysis and incineration is that pyrolysis occurs under inert condition in the absence of oxygen, whereas incineration does not. But based on the research carried out, it has been demonstrated that pyrolysis can be cheaper than incineration.
Now, is there any place where what you're talking about is actually being used? I think I was told Redwood City.
At the Silicon Valley Clean Water Plant.
In Redwood City.
Yes.
And we have a photo of that, of the Redwood City plant, and if we could see it. The first photo, okay.
There it is.
There it is, and I'll talk about that.
You see 6 sort of cylinder-shaped objects in a row there, and you see a large circular building in the back. That's an anaerobic digester back there, and that's the existing treatment plant. Now from there, the biosolids, the sludge, come around in a conveyor belt to this series of cylinders. And what happens, they're drying cylinders, and they're using hot air that's being produced from all the way down at the end where the pyrolysis, the pyrolyzer, is using, is in operation. And through the material is dried, it looks kind of bubbly brown, dried stuff, and it goes through a conveyor belt, it gets ground up a little bit, and then goes into the pyrolyzer, which then affects it with the heat. Oh, there's one of the dryer tumblers there, and it turns it into carbon, which and then the gases that are coming off of it, that's what's burnt to keep supplying the heat to the
Now,
unit.
that carbon also goes into the atmosphere, right?
The solid carbon doesn't. There will be some, you're not going to have totally zero waste, but it's much lower amount.
So what happens to the solid carbon?
It's bagged up, and this is carbon capture and storage at its best. It's bagged up in burlap sacks, put on pallets, and a printing company that makes 3D printing.
We can lose the photo if, so you're saying the carbon is put into,
It's bagged up.
and can be used for 3D printing.
That's what they're using
So
for now.
is this a system, right now the Palo Alto treatment plant is how old? Built in,
Well, most of it's at least 45 years old.
okay.
Yeah. So it is a system that we're looking at. When Dennis first started talking about this, though, we didn't have an example nationwide, really, of where they were successfully using this process, this alternative to digestion. We didn't have an example of that really anywhere in the country. So since that time, it turns out that this pilot plant, it's really more than a pilot, it's full scale, but it's the first one of its kind, happens to be in our backyard here in Redwood City, which is fantastic. So we've already taken some of our material up to this unit, and they've tried it out, and there doesn't seem to be any fundamental reason, even though ours is a different process to get to that point than theirs. It should be okay. So this company that runs the Redwood City facility has actually given us a informal proposal, and we're starting to talk to them in more depth about what it would take to do this in Palo Alto. We'd like a little more data before we jump to that, but it's a very exciting possibility for us. Yeah.
Sure, Aiken?
I think pyrolysis is being practiced in Japan right now. And in the last CSDA conference that we attended, we actually bring this up. It was brought up in the conference that if it is being practiced in Japan and it is being proved to be more cost efficient, why are we not going in that direction? And I'm happy, I'm glad that the regional plants are looking at that option right now, because when you do a cost-benefit analysis, you see that pyrolysis costs less and the benefit is more. And in engineering, it is more. Anything that costs less and has more benefit is attractive. Phil will agree with me. When we talk about engineering projects, we go into cost-benefit analysis, and we're looking for minimum cost and maximum benefit. And pyrolysis fits into that when you compare pyrolysis with incineration. So I'm glad that Phil Bobo and his group are looking into that. And I think if they consider that, it's going to be of immense benefit to the citizens and to the ratepayers.
So let us talk about that cost-benefit analysis and talk about the rebuilding of the treatment plant, how long that's going to take, what it's going to mean over time, and what it's going to mean to local residents.
Yeah. Well, this incinerator, the two incinerators, that's one of the things that's 45 years old. So by getting rid of that, we kind of solve one aging component problem. But there's all the units that you saw in the little video, they're also 45 years old. So you're right that over time, we're going to have to rebuild these features. And the problem is that to move to pyrolysis, which is kind of a subset of gasification, that got a little confusing, but there's this word gasification, and then kind of a subset of that is called pyrolysis. So to put that in place isn't going to be cheap, and somehow we've got to figure out how to do that and how to rebuild all these other units at the sewage treatment plant.
So the question
and not
is,
break the bank.
Yes, no, you said it's not going to be cheap, but would it be cheaper than the alternative?
It looks like it would be, like Aachen was saying. It looks like that once we get this proven, which it's not quite proven to work on sewage sludge yet, I would say. I'm not familiar with the Japanese experience, but this is our first example nationwide right here in Redwood City. So once we become confident that this is really the way to go, it looks like it will be substantially cheaper than what most sewage treatment plants have, the bacteria digestion process. That part looks good. All I'm pointing out is that that's not all we have to do at the sewage treatment plant. Unfortunately, we've got to rebuild all these other things that are 45 years old too, all the things you saw in the little video. And yet, Aachen is saying, well, we've got to keep costs under control, and he's right. So we've got to figure out how to plan all this out so that we don't break the bank, right? So that we have a budget and that the
break whose bank? It would be the public paying.
The public.
This is the taxpayers.
The taxpayers.
You betcha.
The ratepayers, as we call
The
them.
ratepayers.
And it generally goes on the property tax bill as well.
Ah,
Yeah.
so where we see this property tax increase, where it says what, sewage?
It will
or-
say east on, in our district, on your property tax roll, say East Palo Alto Sanitary District, and that's the annual sewer service charges.
Okay, and
Yeah.
in Palo Alto?
In Palo Alto, Palo Alto is a little bit unique because it has its own utility. It doesn't have PG&E, so it appears on the utility bill every month as opposed to the property tax. Most places you see it on the property tax. The sewer bill is on the property tax. But in Palo Alto, they see, gas, electric, wastewater.
Sure. Now, before we get into some other issues, let's talk about, if we could, the partnership. What is this partnership consisting of?
Well, they can chime in, and I'll just remind, one of those slides showed the 6 entities that are the partners to our regional plant. It's the East Palo Alto Sanitary District. I won't do it in alphabetical order because I'll get it wrong, but Palo Alto, Mountain View, Los Altos Hills, and Stanford. Those 6 entities are the partnership. And it's owned, the plant is what we call owned and operated by the city of Palo Alto. And then Palo Alto has contracts with each of those cities.
Okay, so let's talk about the contract. What's the contract with the East Palo Alto Sanitary District?
I think the contract we have right now with the city of Palo Alto is that we have a capacity of approximately 3 MGD, and we are supposed to pay operational expenses, operational maintenance expenses, and we are also supposed to pay for capital costs. Now, on the operational and maintenance expenses, we pay approximately 6%, 6.6% or 6.9% of the overall operational and maintenance expenses. And on the capital costs, we pay approximately 7.6% or so, approximately, of the total cost of the capital projects. That is the existing agreement right now.
Right.
Correct me if I'm wrong, Phil.
Yeah.
How long has that agreement been in effect? Now, you've been with the sanitary district since 2000,
Well, yeah.
when you were the general manager,
Right,
2000
and
to
prior to that,
2002.
I first came on the board in 1982. So, and then the treatment plant, the whole genesis of the thing, the contract goes back, the oldest portion of the contract goes back not long after 1939. I'd have to
Oh,
get,
dear.
yeah, it's all, there's one version I've seen, it's about 1946.
When East Palo Alto when it was an unincorporated
Unincorporated area, and the people who lived there needed a sewage system, and there's a WPA project they started in 1939 and organized and built their own, and their own government governed it and funded it.
Now, Cooley Landing was used as a dumping ground.
That's true.
Was that also for sewage?
No,
Oh, okay.
that was just,
It was just a dumping ground.
right. And you remember Phil mentioned about I think it was 1972 that the Clean Water Act came in. And then there were a whole new standards for sewage treatment. And as Phil mentioned, there were a lot of cities, about everybody had their own treatment plant. Well, the new treatment standard would require expensive new equipment, and not everybody could afford it. It wasn't a good idea to duplicate it, so the feds basically said, if you want our money, you're going to have to combine these plants. So that's why we have the regional plants. We have Palo Alto and Redwood City. So Mountain View had their own plant, and now it's incorporated.
So does that mean the sewage from East Palo Alto is running by pipes
Yes.
into Palo Alto? The sewage from Mountain View is doing
Same
that.
thing.
From Los Altos. That's a lot of pipes running underground from Los Altos Hills to
Yep.
Palo Alto.
That's the way it works.
So when was this system?
Well, it happened kind of gradually. Like, I wish I could answer your question about when the East Palo Alto pipeline joined. I don't know that for sure, but so kind of piece by piece. It wasn't like, one day we all woke up and boom, all the pipes were there. East Palo Alto joined at one point, and Mountain View at a later point in time, Los Altos Hills. So as the restrictions and regulations became more stringent, these entities needed a solution, and sort of one by one we took them on. And then, but most of it came in 1970, approximately 71, when Mountain View, the biggest city actually in our little area, Mountain View, joined, and a big pipeline was built from Mountain View.
Where do all these pipelines run?
Well, they all end up, when you showed that photograph, that aerial photo of the plant, they
Yes,
kind of all...
let's see that. Let's see that
Sure.
aerial photo. This is the Palo Alto Regional Quality Treatment Plant. Can we see it?
It was the one you had
Yeah,
on right
this
at the
one?
beginning. Yeah, there it is. So it's kind of hidden by trees, but on the left-hand side of that is the old part of the plant. You can see some kind of scuzzy, older-looking, smaller tanks and stuff over on the left-hand side. Well, that part of the plant was built in 1935, and at that point, it was just for Palo Alto. But then all of this expansion, the stuff on the right that looks newer, is newer. That's the regional plant that was built in about 1970, 1971. So these pipes come from various directions, and they all end up on the left-hand side of that photo in a, and they, of course, the pipes have to get deeper and deeper because it's gravity flow, right? So they had to keep digging them deeper and deeper. And on the left-hand side of that photo, they come into our pumping plant, and some of them are as deep as 25 feet below ground.
So if I were to go out to, in the front of my house, and there's the storm drain there, and someplace there is the pipe for sewage, we can lose the photo. That pipe runs in the street towards, all of the streets have pipes that run.
Almost all of them, yeah. And they're all kind of merging together and headed downhill. That was the basic thing they wanted to do, was take advantage of gravity.
Hydraulic design work in a particular fashion. Now, for example, East Palo Alto's Sanitary District, our system is mainly run by gravity, which means it's an open channel system. And when you want to design a pipeline, a sewer pipeline, you always design it from the center line of the road. If you choose one lane, if you're going to put it on a particular lane from the center line of the road, you make sure you don't put it in the wheel path. You avoid the wheel path. Because when you put it in the wheel path, then it's going to be subjected to load and the trench is likely to collapse. So following this principle,
the
wheel path.
Where the wheels go.
The wheel path, yes.
Exactly.
From a
You
big
always
truck or
avoid
something.
that. That is how it is designed. And you go and avoid all existing services as much as possible. And you also avoid the wheel path as much as possible until you get to the
How big are
outflow.
these pipes? Are these the huge?
Some of them.
It depends on the size of the pipe, depends on the flow rate, and it depends on the slope. If it is very steep, you can use a smaller size pipe. If it is very flat, then you have to go to a larger size pipe to get the same flow rate.
So
Wait,
who made? Yes.
I
go
was
on.
just going to say, just to give you the sense of the full range of these. So the smallest we like to see, because you don't want them to block easily, is about a 6-inch pipe,
6 inch.
like that, right? That's the smallest. The biggest one we have is that new one from Mountain View that I talked about, and that's 72 inches. So
6 feet.
6 feet. So
Across.
that's yeah.
Circumference.
Well, the diameter.
So we're all the way from Mountain View to
Yeah.
Palo.
So
Does
that's
this run around the creek, around shoreline, or?
It kind of runs through the Baylands, actually. We probably wouldn't be able to do this again today. It's parallel to the freeway, but on the east side of the freeway in the Baylands. So, yeah, you've got this big 6-foot
So
pipeline.
you said you probably wouldn't be able to do it today. Why not?
Well, because it runs through
Wetlands.
habitat, wetlands. Yeah. And
Wouldn't
then-
that be the safest place rather than under the street?
well, some would say so, but it's very hard to get things permitted through wetlands these
So
days.
what
I have an
happened?
example of that. The East Palo Alto's trunk line goes to San Francisco Creek near the bridge end of O'Connor Street. Then it goes through a siphon that goes under the creek, comes up and goes along the airport over to the treatment plant. And we replaced the siphon, added a siphon to bring recycled water back in the future. And we had like, what, about a 5-week construction window because it couldn't be in the nesting period of certain wildlife. And the whole process of permitting took 7 or 8 agencies, including the Santa Clara Valley Water District, and several years as part of the realignment of San Francisco Creek. It was a long process and took a lot of permitting.
Who pays for all of this?
Taxpayers.
Taxpayer.
From each city. So the city lines from each city is paid by that city's taxpayers.
Correct.
Exactly.
Yeah, you know, one thing to point out about this whole funding problem that we're having, trying to find the money to revitalize the plant. When these plants were all first built, just to go back to a historical note, being the oldest person here, I'll be the one
Born after 1960.
to... No, I was not accurate about that part.
But that goes for all of us.
Originally, when these plants were built in the early 70s, like most of them were, they were funded by 75% federal money and about 10% state money. So the locals only had to come up with less than 10%. And that was then. And that was actually a grant. That was free money from the federal government because everybody recognized, hey, we have to solve this problem nationally. And the federal government put literally billions of dollars into it. Well, those grant programs are gone. And the federal government has said, and it's not just the current administration, even though...
That would not give money to California, right?
Well, I'll let you say that. But even before that, this era, the federal government had gotten out of the funding business of sewage treatment plants. And the locals are left to try to figure out how we're going to rebuild these plants, how we're going to put in the newest and greatest technology. I just wanted to point that out. So we've got kind of a fundamental problem with the federal government first funding them and then backing away.
So, Aiken, you mentioned that the East Palo Alto Sanitary District pays 6%.
Plus minus.
How is that calculated? What I'm saying is, I would assume each city pays a different percentage.
You are correct.
Does it?
Correct.
You are correct.
So how is that?
Now,
how
when you
is
want
that
to
figure
calculate,
derived?
when you treat
You've hit a
wastewater,
sore point here with him.
now when you treat wastewater, the treatment cost is a function of the flow rate, and it's also a function of the chemical components, you know, the contaminants. So, according to Phil, the 6% was calculated based on flow rate, and the 7% was calculated based on flow rate and strength. And I and Phil have been discussing that we need to actually renegotiate that deal.
I would assume you would want it lower, right?
I want to know, and we've been talking
That's the
about
bottom line. But I think sort of the bottom line, the answer to your question is, roughly speaking, it's those percentages are based on the amount of water that they deliver. So they're, from East Palo Alto, we get about 6 to 7% of the flow comes from East Palo Alto.
Now that depends on the population,
Yeah,
of
yeah.
course. And East Palo Alto's population is what, about 30,000?
Yeah, about it.
So is this low in comparison to Palo Alto, which has a population of what, more than 50,000?
That's a good question, because if you just look at population, it's not the total answer, because Palo Alto is like, let's say roughly 60,000. East Palo Alto's say 30. So you'd think, oh, well, Palo Alto's percentage must be about twice.
Yes, you would think so.
It's more than that.
It's more than that.
Palo Alto's percentage is more than
is
that.
a lot more than that.
So what are the factors that go?
It's the businesses, right? Palo Alto has a lot more office space, and it used to be industry. Now it's lawyers' offices, right? So, and what's the other thing called? Venture capital firms and stuff like that. But anyway, Palo Alto's daytime population is 3 times its nighttime population. So we have about
Which
3
is
times as many.
residential.
Yeah. So we have about 3 times as many workers coming into Palo Alto as we do people actually living
So
in
is Palo Alto paying 3 times as much?
Yeah, it's paying, Palo Alto, it's even more. Palo Alto's paying about 35% of the costs, whereas East Palo Alto is paying 6-7% of the cost. But it's, I don't feel, I mean, I'm not worried about Palo Alto's share. I think that's fair. Akin would argue the other way, that actually even at 6-7%, that's too high. So that's why he and I are having discussions about that.
Well, I don't want to give you ammunition, but East Palo Alto's having more businesses now, right, with Amazon
I think so. Yeah,
I'd like to speak to
We're
that.
getting there.
Oh, okay.
Because see, historically, we made a purchase of capacity in the treatment plant and a renegotiation of the contract, maybe 20 years ago. And the reason we did that was the city of East Palo Alto brought a new general plan then. And in the general plan, at full build out, would require more sewage capacity. And see, our duty is to serve the demand as it comes and not try to influence the development or how it goes. It's just there's a demand, we try and serve it. So we spent the money and reserved the existing capacity. Now the general plan is being redrawn at the city of East Palo Alto, and with some of the businesses that have been looking or proposed, that's going to require a lot more capacity. We also, as I mentioned, we put the recycled water pipe under the creek because we'll never be able to get back in there and get the permitting to do that again. And so we'll be able to bring quite a bit of recycled water back to these proposed, there's 1.4 million square feet of office space down near the old Romic site. There's what you call a data center or something.
Data center.
That's saying they're going to use incredible amounts of water.
Technology.
Yeah.
So the rate would be going up, would it?
No, they're going to pay for that.
They're going to pay for that. The rates will be going up not because of the upcoming businesses, but because of the cost of rehabilitation of the treatment plant.
Yeah.
And then Phil Bobo, we've been talking about how to minimize the cost. Because
To the consumers, to the
consumer,
residents.
To the residents.
Or minimizing the costs of the treatment plant in general.
Exactly. We've been talking about that. Because that will help improve business confidence.
Sure.
One thing that we didn't start rehabilitating this plant probably as early as we should have. But the good news for that, when you look at the cities north of East Palo Alto that feed into that Redwood City plant we've been talking about, their rates are all substantially higher than the East Palo Alto Sanitary District. Even Dennis will agree with me on that.
Yes, absolutely.
Why? Because if the plant is more efficient, right?
Well, there's several.
And it's, yes.
Well, this new technology at the plant actually became functional sometime about February or March. It's only been functioning about a year. So there's already all this other infrastructure at the plant, the big concrete stuff and everything. They're still paying for that. Those generally, it's like a 30-year mortgage on a lot of concrete when you do a treatment plant. It's your fixed assets there. And also in West Bay, our neighbor, our rate's $575. West Bay, I think, is $1,050 or $1,100. If you go to one of the streets in East Palo Alto has West Bay on one side and us on the other. And one of the reasons that is they kept their rates low and didn't invest in fixing pipes and infrastructure, which we have always been proactive in doing.
So who maintains these pipes, and how do you determine whether they're still in good working order?
For example, in East Palo Alto, we maintain our system, our collection system. And this is there's so many technology out there that you can use to determine the condition of the pipe. One of it is the smoke test. You can carry out a smoke test, and when you carry out a smoke test, the smoke test will let you know if there are holes in the pipe.
What's a smoke test?
The smoke test is a particular chemical that is put in the manhole, and they burn it, and it releases a smoke that travels along the longitudinal section of the pipe. And once it travels, then they will now go with some instrument, travel in the same direction on the ground, and we measure the concentration.
Is that when there's a large truck that comes along and this big hose is stuck?
They put the chemical in the manhole, and they burn it, and it generates smoke.
Test.
And that smoke goes through the pipes. And they will now travel, they will walk along the longitudinal section of the pipe to measure the concentration. And that concentration is a signal of if the pipe is leaking or not.
And how do you then dig up the streets to fix the pipe? You dig up the street?
Not necessarily. We'll do a cost-benefit analysis. Do we dig up the street? Depends on the traffic. If the traffic is very high, we might not choose to do that.
You'll just let it leak?
No, we might go into slip lining.
Oh.
Trenchless technology. We might go into slip lining. We might go into
Which is?
cured in place. Slip lining, what that does is that they take a plastic, they melt it, they heat it a little bit to make it flexible, and they push it with certain technology along the longitudinal section of the pipe to actually form another pipe. It's like you are coating the existing pipe with a thickness, a thin pipe inside it to prolong the life.
Okay, so it seems with all that's going on, we're moving in the right direction, are we? It's going to
Absolutely.
take us a few decades
It will. And we have
to
to
begin
space it
to
out.
reduce the greenhouse gases and
And we have to space these expenditures out so we don't have rates increasing at a huge rate. But they are going to increase.
now, one thing people want to know, we saw in the video that the recycled water is used for watering industrial uses. But we've heard about recycled water for drinking purposes.
Yeah, that's recycled water right there. I brought you some. Just kidding.
No, you didn't.
Just kidding.
I know this came out of the kitchen, and
Oh,
unless you were in the kitchen. So, do we deal with recycled water as wastewater as drinking water?
Well, let me give you where we stand on that. So they are definitely, in parts of the world, desalinating water and drinking
From
it.
the ocean.
Yeah, from the ocean. But I think the Israelis have already started desalinating wastewater and reusing that. I'm not sure about the drinking level. But here's the different levels. So what we're doing right now, as we speak, is taking the treated wastewater and irrigating with it. And people call that recycled water. We call it recycled water.
Now, presumably that recycled water doesn't have toxic chemicals,
Well,
or a minimum of toxic chemicals.
Yeah, there are some, and that's why we're not drinking it. But we're using it for irrigation water. And
But wait a moment. If you're using it for irrigation water, and okay, it's not coming out of our pipes, out of our faucets.
No.
Okay, so
it's
if
a
I'm
separate
gardening,
distribution system.
if I'm gardening,
Yeah.
I wouldn't be using it.
Well, you wouldn't be drinking it because it doesn't meet drinking water standards, but it's safe to be around. It's not going to harm you if you get it on your hand.
And if it's
you,
in my food, my vegetables that I'm growing.
And that kind of thing has been tested, and there's not enough uptake. We wouldn't say it's zero, but there's not enough uptake in vegetables that it is going to cause a problem. That's been well tested.
What type of toxic chemicals are we talking about?
Well, the thing you worry most about is metals because they don't break down. So things like zinc, copper,
Boron.
yeah, boron,
Like
Boron.
things
Lead.
that are elements like that, they don't break down. And so there is a concern over the long period that they'll build up in the soil. So there's all kinds of tests being done at universities and special studies to establish long-term rates so that we don't overdo the irrigation in a given area. But we've done enough studies on vegetable crops and all kinds of crops to know that there's not enough of a dose that's making its way into these plants that we would be worried about eating the tomato. There's just not enough to cause a problem.
No more flame retardant tomatoes.
Well, yeah. So
You have to-
there's a pollutant, there's a new pollutant almost every day that we discover that we should be worried about, right? And the flame retardants, I would say about a decade ago, we realized, oops, here's another one. This family of chemicals that has been used as flame retardants, and they're used in such a high percentage, like in couches and stuff. I never realized how much of that flame retardant they put in some of these household things like couches. But anyway, so we're going to have to continue to be vigilant, and as man dreams up and woman dreams up yet another chemical to add to our onslaught of chemicals, we're going to have to test that one and make sure that that one doesn't run the risk of building up as well.
I would like to speak to what Phil is saying. Recycled water can be treated to drinking water level. And Phil will agree with me that the technology is there. We have membrane technology. It's been proven that you can actually take recycled water and treat it to drinking water level. that will meet the Safe Drinking Water Act of 1972. The problem, and that is what is called portable reuse now, the problem is the public perception. That is why you don't have it common. You know, it's not yet accepted by the general public. But the technology is there to treat recycled water to
Can it
drinking
be
water.
treated in the current treatment plant?
No.
No.
You'd have to add a process.
A
So,
membrane process.
yeah. So we're kind of about to launch on kind of an in-between step. Right now, we don't have that kind of process. We're not removing enough of these strange chemicals that you'd want to drink it. But it's pretty high quality. It looks completely clear, and it's good for irrigation water. Well,
You can't
pretty
tell
much.
by looking
I know. I was just trying to give you a feel for
what
you
it
know,
looks like.
Yeah. So the first step for us is to reduce the salinity of the irrigation water, because some people are worried about the old-fashioned salt in our current irrigation water. So we're going to put a relatively small reverse osmosis plant, it's called. It's the membranes
Membrane
that
technology.
Akan is talking about.
So that water, the recycled water, is not coming from the ocean, right? So why should there be a high level of salt?
Well, it's not all that high. It's much less salty compared to the ocean or something. It's fresh water, but certain very sensitive plants, like redwood trees, the literature shows that it should have an even lower salt content than our current irrigation water. So we're going to put one of these small membrane plants in at our sewage treatment plant. Again, over on the left-hand side of that drawing is where we're going to stick it. Enough, and remove enough salt that everybody will be comfortable with using it even more for irrigation water. So that's great. That's our first baby step. Remove some salt and improve the quality of our irrigation water. The next step is what Akan has talked about, and we don't have plans for that yet, but I think it's coming. And that is to remove more salt, to remove all the toxics that you'd be worried about, and actually probably inject it into the ground, into groundwater, and then pump it out of the groundwater. That'll give people another sense of security, right? They're not drinking it directly from the treatment plant.
Let me give you the last word just in a few seconds.
Okay. Well, one thing I wanted to say, even if no one ever dumped any pharmaceuticals down the drain, people's bodies don't use them all. So it's going to get passed through their digestive system. They're going to show up in the water that needs to be treated. There are a lot of, these things come, and there are a lot of challenges that are subtle and take a lot of work to remediate.
Well,
I think I would like to speak to that a little
just
bit.
a second, a second.
Pharmaceuticals and endocrine disrupting chemicals, we call,
Yes.
are emerging contaminants. It's not yet been regulated, but it's exactly what Director Sheza is talking about. But it's been proven that the EPA in the future might regulate pharmaceuticals, and that's what he's talking about.
Well, we have learned a lot. You have talked
More than
about
you want.
You've done a great
Well,
job.
as much as we need to learn, we can't learn enough. But I'd like to thank you so
Thank
much
you.
for giving us the information that you've given us. And I'd like to thank our viewers for watching. Until next time.